This is 12.4a. We're going to talk about the logarithm of a product property, and I have a theorem for you. I was going to do all the basic properties in one video, but I realized it was going to be over 45 minutes long. So I'm breaking it into several videos. We have 8 for this chapter 12 so far, and they're linked in this description if you need help. So logarithmic functions share similar properties with their exponential counterparts, and I'll show you that in a little bit. When needed, the properties of logarithms allow us to manipulate the log expression so we can solve equations or simplify terms. And just as with exponential functions, the base of a log function has to be positive. So here's our theorem. It's for the log of a product for any positive numbers x and y, and a is greater than 0 and it doesn't equal a 1, log base a of x times y is going to equal log base a of x plus log base a of y. So we've got multiplication inside the parentheses. We've got a plus sign over here. That's really important to pay attention to that, all right? So this theorem states that the logarithm of a product is the sum of the logarithm of the factors. Now remember that the base a must remain constant. So the product is going to equal the sum of the factors. Okay? So we've got log base 2 of 4 times 16. We can express this as a sum of logarithms. We can simplify it if possible. It's going to equal log base 2 of 4 plus log base 2 of 16. Now we've learned in the last few videos that it's asking us 2 to the what power is 4 and 2 to the what power is 16. See? Well, 2 to the second power is 4, and 2 to the fourth power is 16. So our exponents are a 2 and a 4. So this is going to be a 6. It's the same thing as saying log base 2 of 64. 2 to the what power is 64? 6. 2 to the 6th power equals 64. It's the sum of the factors. See? This is the sum of these factors. All right? We have log base a of m times n. It's going to equal log base a of m plus log base a of n. If we have log base 5 of 25 times 5, it's going to be the sum of the factors, log base 5 of 25 plus log base 5 of 5. 5 to what power gives us a 25 to the second power? 5 to what power will give us a 5 to the first power? 2 plus 1 is 3. It's the same thing as log base 5 of 125. 5 to the what power gives us 125? 3. See how it works? So we just do the sum of the factors. See? Now you have to be careful. Notice that we have a multiplication sign in here and an addition sign here. We can't flip them around. We can't put addition here and multiplication over here. See? It's got to be multiplication inside here in the parentheses and then addition here. If we try doing it this way, and let's say x is 8 and y is 4, well then we're saying that log base 2 of 12 needs to be equal to this multiplied together. Well, 2 to the what power is 8? 3. 2 to the what power is 4? 2. 3 times 2 is 6. If we do log base 2 of 12, got to use our calculator, it's going to come out approximately as 3.59 for our exponent. So that didn't work. Now, it would work if we switched the signs, like we did over here. If we put multiplication inside here and did 8 times 4, that would be a 32. 2 to the what power is 32? 5. And if we put the addition sign on this side, we would have 3 plus 2, which is a 5, and it would work. See? So it works when there's multiplication in here and addition out here. See? It also doesn't work if both sides are addition. So we saw that this addition side made an exponent of 3.59. Okay? Well, if we did addition here, we'd get 3 plus 2. That would be a 5. It doesn't work if both sides are addition. The logarithm of a sum is not the sum of logarithms of the addends. It's got to be the product, okay? So it doesn't work if there's plus signs like this, okay? They're not equivalent, all right? We can express this as a single logarithm. we've got log base 3 of 9 plus log base 3 of 27. We just put the 9 times the 27. It's going to be log base 3 of 243. We can even work this out to see if it's true. 3 to the what power is 9? 2. 3 to the what power is 27? 3. So that's a 5 when we add them together, okay? 9 times 27 is 243. 3 to the what power is 243? 3 to the 5th power. So it worked, see? We would take the 19 and the 3, we would multiply them together, and we get log base 5 of 57. Isn't that easy? This would come out as a decimal. We'd have a rational exponent for 5, okay? And look at this one. We've got log base 3 of 7 plus log base 3 of 5. We put the 7 and 5 together, we get log base 3 of 35, all right? So now we're going to get silly. So we've got this one, and when we put them together as products, see they're all addends, when we put them together as products, we would end up with log base A of C-A-B-I-N. We'd have a log cabin. See? Even my little I says that's silly. Now, there's a parallel between this property of logarithm functions and exponential functions. If we have log base A of x times y, it's going to equal the sum of those factors, log base A of x plus log base A of y. And if we plug in an 8 for x and a 4 for y, we're going to get a 3 plus 2, aren't we? Well, if we put this 3 and the 2 here, we'd have a to the 3rd power and a to the 2nd power. That would be a to the 3 plus 2. That would give us a to the 2 to the 5th, see? If we put our base 2 here as a, it would still be 2 to the 5th power, just like this would be 5, see? So what we're going to be doing over the next few videos is these properties of logarithms, all right? So I've got them all spelled out here on my second board here. All right, let me back up a little bit. We did equivalence in 12.3a, and that's where we said y equals log base a of x is equivalent to x equals a to the y. I had that in my little rectangular box. We have an example here. And when you see this equal sign with arrows on each side, it means equivalence. You might even be able to just see in your textbook or from your teacher a double-sided arrow. That means equivalent, okay? And we just did log of a product. This is 12.4a. We're going to do log of a quotient, of a power. We're going to do log of 1 and log of the base, all right? So I'll show this again. I'll show it at the end of each video, all right? So this is the one we did just now. The factors become the addends, okay? All right, so the next video is 12.4b. We're going to talk about the logarithm of a power, and I have a theorem for you. So we're going to do this one, okay? Looks like plug, doesn't it? All right, so I'll see you next video. I'm proud of you for getting this far in algebra. I think you're doing great. Little baby steps, and I'll see you next time. Bye.